We are going to start looking at graphing polynomials. So we have looked at, last section we looked at finding the zeros. We looked at end behavior. So we're going to kind of put everything together to be able to sketch graphs so we don't have to get our laptops out and graph it. We can kind of just looking at different parts of the equation, kind of develop that knowledge. And this is great if you don't need the exact graph, but you're just kind of like looking at on what interval is there a maximum. You know what's going to happen as you go to the right or go to the left, to kind of anticipate that. All right, so we're going to graph polynomial functions by hand or using technology, identify zeros when suitable factorizations are available and showing end behavior, and recognize even and odd functions from their algebraic expressions. So end behavior is exactly what it sounds like. It's what are the ends of a graph doing. So if you're dealing with a function, you have two options. You're either going to positive infinity or you're going to negative infinity. And we had used specifically arrow notation. Most of you, when asked for the end behavior, could say it's going to positive infinity, going to negative infinity. Still working on the function notation or the arrow notation for that. But as long as we know what direction it's going, that's the most important part. So what we're going to do is look at number 1. So each graph below shows a polynomial of the form f of x equals blah, 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 where a sub n does not equal 0. Apply what you know about graphs of polynomials to match each graph to one of the equations below. Write the equation under the graph, justify your answers. All right, so we have a few graphs there. What I want you to do is to kind of just look at them and identify what equation could go with it. Now, keep in mind some important things. When we talked about an odd function, the highest exponent for an odd degree function is what? If it's odd degree, the highest function is, what does odd tell you? An odd number. So it's either, if it's an odd function, it's odd degree function is 3, 5, 7, one of those. If it's an even degree function, the highest degree is an even number, right? So 2, 4, 6, 8. If it's an odd degree function, what do we know about its end behaviors? And think about the cube root, or the cube, like x cubed function. What does that graph look like? Right, you have one side's going up and the other side's going down, right? And if you think of an even degree function, the most famous one would be the quadratic, y equals x squared. What's that function look like? Right, they're both going up, correct? So use that to kind of narrow down your options. If it's an odd degree function, what's the end behavior? One is up and the other is down. If it's an even degree function, both ends are either up or both ends are down. If it's an even degree function and both ends are pointing down, is it a positive or negative? Negative. And think about what happens if you think of the graph y equals x cubed. What does that graph look like? Is it increasing from left to right or decreasing? So is it, positive end behavior as you're going to the right, or is it positive as you're going to the left? And think about what that negative coefficient at the front does. So let's take a moment to do that. So use the. All right, so looking at A. So if we look at A, is that one going to be odd or even? It's going to be odd, right? So now we have a few odd ones. So looking at this, how many zeros could this one have? How many terms? It was 3, right? So we have 1, 2, 3. So this one, it's going to be one of these. So now we need to determine, is it going to be the negative or the positive? So now think about y equals x cubed. What does that graph look like? Is it, as you move right to left, is it, you know, which end behavior is positive? Is it positive on the right when it's positive, your leading coefficient is positive, or when it's negative? Right. So A probably goes with this one, right? The y equals positive 2. So I need to unfreeze the board. Y equals 2x cubed. All right, and then in B, is this one odd or even? It's even, right? Because they're both going down. So since they're both going down, is our leading coefficient positive or negative? Negative. And then looking at this, how many possible zeros does this one have? 4, right? Because we have 1, 2, 3, 4. So this one would be the y equals negative 3x. All right, so then guesses on C. All right, so as we are moving from left to right, our end behavior is going to positive infinity, so we're looking at our positive. So write that out. Put an arrow. All right, so then so questions so far? So it's not so bad, right? Kind of when you break it down and look at all of the bits that we know. So D here, which did you choose? Right. So as we're moving from left to right, we're going to negative infinity, so our leading coefficient is negative. And so we have a total possible of 3 possible roots. So this would be y equals the negative 2x. What about E? So this one was the 4th power, right? Was it? And then this last one, it's like C, but reverse, so this would be the negative 1 to the 5th. All right, so feeling okay with that? All right, so polynomials can be written in factored form or in standard form. Each form provides useful clues about how the graph will behave. Work on item 2 with your group as needed. Refer to the glossary to review translations of key terms. Incorporate your understanding into group discussions to confirm your knowledge and use of key mathematical knowledge. So it says sketch a graph of each function for graphs B through E. Identify the information revealed by the unfactored polynomial captured to the factored polynomial. So let's start with A. So what's our highest power on A, which is f of x equals x plus 3, 1. So what's this graph look like? It's a line, right? We have a straight line. So what do we know about this line? What's our y-intercept? 3, and what's our slope? 1. So it's pretty easy to graph, right? We should be masters of looking at that and immediately saying, oh, y-intercept of positive 3, slope of 1 over 1, nice straight line. Now for B, we have g of x equals x squared minus 9. So in this form, what does this tell us? What's our y-intercept? Negative 9. And then our x squared, what does that tell us about our end behavior? They're both going up, right? Because it's positive and it's a square, so we know both ends are pointing upward. So that tells us a bit of information. And then what does the factored form? What does x plus 3, x minus 3, what does that tell us? There's one positive, one negative. And what are these called? Which is those are our zeros, right? So this tells us where we're crossing the y-intercept at, and it tells us where our ends are going. And this is telling us where we're crossing the x-axis. So if I wanted to graph that real quick, there's my -9, there's my y-intercept. This x plus 3, if I set that equal to 0, that's 1, 0. Okay? Set this equal to 0, that's my other 0. And then, so here's my y-intercept, here are my two x-intercepts, and I know my ends are both pointing up. So that was pretty easy to graph without pulling out a calculator or pulling out Desmos, right? So knowing how to graph that can save you some time. So looking at C, our leading coefficient is positive. Our highest degree is 3, so that's odd, right? So this is telling us that we have at most how many zeros? At most 3. We know that as we're going from left to right, our end behavior, right, our left is going to negative infinity, our right is going to positive infinity. What's our y-intercept for this one? What's our 0, our y-intercept? So our y-intercept is -9. Let's write this out. So as x goes to positive infinity, our y goes to positive infinity. As x is going to negative infinity, our y is going to negative infinity. So that's our arrow notation. So that's what that's telling us. And then we factor it out. We have our 3 roots. We set these equal to 0, and that's what's crossing the x-axis, right? So here we have x equals -3, x equals +3, and x equals -1. So if I graph this out, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have that, and then I have a 0 at -3, 1, 2, 3, -1, and +3. All right, so I know as I head to the right, it's increasing, right? So I'm going to go here, and I have to hit my y-intercept, come back up. I don't know how high I'm going to go, but I am going to go go up to a point and then come back down through here, right? I can assume that my max is going to be somewhere halfway in between there, right? Makes sense. And then I'm going to come back down. So that's like a rough sketch. I know I have a minimum between these two. It's probably not exactly here, but I didn't draw it real great. But I'm going to have a min between -1 and +3, and I'm going to have a local max between -1 and -3. So I have a sketch. I have an idea of what the shape of my graph is going to be. All right, so what I would like for you to do is to try to sketch D. So look at, okay, what are my y-intercepts? What's my y-intercept going to be? My highest power is 4, so what does that tell me about the end behavior? At most 4 zeros, yeah. We're going to have 4 zeros. Do the zeros always have to be real zeros? No, but it tells you how many terms it's going to have. And so then they have the factors form with all 4 zeros. So for E, we just double them. Yeah, this is called multiplicity, and it means we have multiples of them. So we can rewrite this as x times x plus 2, and this squared is telling us that we have it twice. Well, here we have 1, 2, 3, so that would give us, multiplying it, that would be x to the third, and then x plus 3, that has a multiplicity of 2. All right, and so multiplicity tells us something. We haven't quite got, we'll talk about that here, I think, soon. I don't remember which one it appeared in. Bless you. So this one, so here we have 1, 2, 3, 4, 5, right? We have, it factors into 5, but it really only has 2 roots, right? Or I mean 3 roots, because we have one at 0, one at -2, and one at -3. And so let's look at the demos to see how that affects our graph. So for this one, where was our 0 at? We don't have a number on the end. So what's the number? It would be like plus 0. So our y-intercept is at 0. We're utilizing our resources. All right, so someone's gonna have to read it to me. I can't get the computer to cooperate. Yeah. Right, 10x to the 4th plus 37x 16x squared. Thank you. All right, so if we look at the graph that Savannah did over there, through each of our zeros, we passed on through, right? And then we came back up. There was like a low point or a high point about halfway in between them. But here at -3, we're not passing through. What's it doing? It's stopping and then turning around. Same at -2, right? Going to that point and then turning around. And then our other 0 was at 0, and there we're passing through. So multiplicity, we'll learn, kind of changes how your graph reacts at a 0, at your x-intercept. That one's fun. It's interesting, right? All right, so right now we have learned, we've kind of just taken the knowledge that we've learned previously over the last couple sections and kind of brought it all together to sketch graphs. Do you guys have any questions over that so far? All right, so polynomial functions are continuous functions, meaning that their graphs have no gaps or breaks. These graphs are smooth, unbroken curves with no sharp turns. Graphs of polynomial functions have degree n with n zeros. And so we learned that last section with the fundamental theorem of algebra, that the highest degree is the most number of, or is the number of zeros. No, but we also learned that not all of them are real zeros, right? Sometimes you have an imaginary 0. So we'll look at how that affects a graph too. Let's see, so they have, so the relative extrema would be your local max and mins, right? So looking at Savannah's graph, This was a fourth degree polynomial, right? We had 4 roots. And so we have how many extrema? We have a min here, a min here, and then a max up here. So there's 3 extrema, right? We have 2 local max and 1 local minimum. If we think about a quadratic function, how many extrema does a quadratic have? I think of x squared. So it has 2 roots, right? But how many? It either has a tippy top or a bitty bottom, right? So it has 1. What about a cubic function? That has at most 3 roots, right? And then how many max or mins can it have? It can have 2. Right, I'll have a max here and a min there. So how's the relative extrema? How does that compare to the power, the highest degree? 1 less, right? So if you have a quadratic, your highest degree is 2, so that means there's 1 max or min. If you have a cubic function, you're going to have 2 turning points. You'll have, 1 max, 1 min. If you have something x to the 20th power, how many relative extrema are you going to have? 19. You'll have 1 less. And so that's your turning point. So you'll have, 19 turning points. So number 7, find the x-intercepts of f of x equals x to the 4th plus 3x cubed minus 2x minus 3. So just kind of talking about what we know. The shape of this graph. What do we know about the end behavior? They're both up, right? Both even and positive. How many zeros can it have? It can have 4. How many turning points? How many relative extrema? 3. So we already, without even graphing it on the computer or whatever, we already have an idea of what it's going to look like, right? So it says find the x-intercept. So looking at all 4 terms, I have 4 terms, right? So I automatically think grouping. All right, so let's group, if I group the first 2 and the second 2, looking at the first 2 terms, what do they have in common? They have x cubed in common. So when I take out x cubed, x to the 4th, dividing out x cubed, what's left? All right, so now this is positive, that's negative. So what do I need to pull out so that can be positive? I'm going to pull out a negative. And then Bodhi said negative x. So if we do that, negative x squared, pulling out negative x, what's left? And then negative 3x, pulling out an x plus 3. All right, so these are the same. So I have x plus 3. And then what's left? All right, so I want to find zeros. I have 1 0, right? All right, so looking at this, can I factor that further? I can take an x out, right? So x plus 3. I take out an x. So when I take out an x, what do I have? X squared minus 1. All right, so x squared minus 1. Now that has a middle term of 0, correct? So x squared, I can rewrite it. So I have a quadratic. So now all of a sudden I have 2 zeros. I have 2 of my zeros. So I can either use the quadratic formula to get my other 2 zeros, or if I look at this, I need 2 numbers that multiply to give me negative 1. Same 2 numbers, when I add them together, I get 0. So negative 1 is nice because I only have the option of positive 1 and negative 1, right? And when I add positive 1 and negative 1 together, what do we get? 0. So now we have all 4 of our zeros, right? And we used lots of skills, factoring skills for that one. We used grouping, greatest common factor, and we used what we know about quadratic factoring. So what are my 4 zeros here? And what's my other one? What's this one? 0. So I have zeros at -3, +1, -1, and 0. What's the x-intercept of this? If I put 0 in for x, where am I crossing the y-axis then? At 0, right? All right, so then this one says, how can the zeros of a polynomial function help you identify where the relative extrema will occur? Well, if I know that my x-intercepts are there, right, so I'm going to cross at -3, 1, -1, and 0. Halfway in between, I'm either going to be at a relative max or a relative min, right? Because it's when my graph turns around, it's always in between zeros. You know, I don't have like a sharp decrease and then, you know, gradually going up to the next zero. So we know that halfway in between -3 and -1, I'm going to have either a max or min. Halfway between -1 and 0, there's going to be a max or min. And halfway between 1 and 0, I'm going to have a max or min. Exactly what it is, I don't know off the top of my head, but I know that I'll have one in between them. Which is useful because if you're in, you know, at your job and you're trying to figure out, you know, maximizing, you know, inventory or production or something, you know, and this, you know, this is your graph, the equation for your graph that the computer spit out, you can kind of estimate, well, you know, if this is a min in between here, well, then you want to be in between here or on the other side of 1. You know, to kind of give a ballpark so you're not testing random points, you're kind of making educated guesses. All right, questions so far? All right, so number 10, the relative extrema for our function f of x equals x to the 4th plus 3x cubed minus x squared minus 3x occurs at approximately x equals 0.6, x equals -0.5, and x equals -2.3. Use these x values to find the approximate values of the extrema and graph the function. All right, so this is telling us that it's telling us where the extrema is occurring, which is kind of where we have looked. So looking at this, if I know that I'm going to have an extrema at about this point, I can find it, right? I can substitute 0.6 in for x and then get that max value or min value. So let's just go ahead in the next couple minutes. Let's substitute 0.6 in to our function. So why don't you, this group, put 0.6 in, this middle group put -0.5 in, and then this side put -2.3 in, and so we can get that graph. I just erased all of my zeros. So we had, this was, our y-intercept was at 0. We had one at +1, -1, -1. And the negative 2.3, where do you get that at?
Power 4 3. Twice.
No, that's it. You have to use this one. So you put in negative 2.3. Or let's see. I think that was right after.
It's the same thing as
Oh, it
the
was.
x squared. You want to like get all the way down to one
What
number?
was it, 27 something?
27.9841.
27 point
9841.
984.
What do you get?
You guys had the 0.6, right? Oh wait, but you have to do the rest of
Yeah,
the
yeah, we were.
Okay.
Oh, yeah.
Negative 1.1. 125. Yeah. Wait, do we have to? Yeah, we can. I'm gonna start it at 1 second. Yeah. It's basically like the same thing that we did, but it's way easier. You don't have to use this. No, sometimes he does. Like dimensional analysis for it. Dimensional analysis for it is literally. Alright, so let's look at this. So it's even, so we know both are going up, right? So that means that this, we're going down. And so we have at negative 2.3, we're at almost negative 7. Now, let's double check this one. Is it negative or positive?
I got positive.
Okay. The same number? And then this one. I missed that zero. It's supposed to be going through that one. So our graph is going to look something like that. With our extrema now found, so that we have those numbers. Alright, so we'll stop there. We only have a couple minutes left.